first thing we want to do is make sure that our turns ratios and our encoder counts are set up reasonably close to what they are. In this case, if we left them at 5, that would be fine, 8,000 counts per rev. We just want to, if you change your motor res per inch and your coder counts per unit drastically, you will change your tuning. So you want to have that, even if it's just with a tape measure, come in and get it eyeball close, if you will. Now this machine, as I mentioned, you notice the 4th axis is paired with the X-axis. That, in years past, before CNC 11, we couldn't tune a slaved axis. We just had to guess. We winged it. We said, well, these numbers look okay. It's behaving kind of okay. Now, in this case, we can. First thing I'm going to do is jump into a different coordinate system, just in case they happen to be. Use my coordinate system. And then I'll set my zeros right where I'm at. Cycle start. All the tuning's done in the PID menu, so you go into F1 setup, F3 config, enter the password, F4 PID, F4 PID config. First thing you want to do, you'll notice up here that we're looking at the X-axis. That's fine. That's the first one we're going to do. If you press F8 and toggle, you'll see it says change axis. So that'll change from X to Y to Z. And it'll cycle through any active axis you have. So make sure you're going to be actually viewing over here in the oscilloscope window the axis that you're tuning. Then we'll come in here and we're going to edit the program. As you can see, the last thing we did in here was the Z axis. We'll change that back to X. What I like to do is I'll do a move that's 1 second out and 1 second back. So we'll start with 30 inches a minute. And at 30 inches a minute, it takes 1 second to move a half of an inch. That'll help when we get back to the screen and we're looking at our feedback. It'll scale really nicely. We'll get a full shot going one direction and coming back the other direction. So I'll start at 30, and from there I'm just going to scale it 30 to 60, and I'll double my I'll double my distance that we're moving as I double my feed rate. So we'll start at 30 inches a minute, moving a half of an inch. Close that, and you'll hit run program. Okay. Now at this point we're all set. We have to hit cycle start. I'll let it go back and forth a couple times just until I can see a full waveform going one direction, a little bit of a dwell coming back the other direction. Then I'll hit zoom off. First thing I'll adjust, we generally always start with KP around 0.1. Okay. I'm going to zoom out just a little bit so you can see. This looks like a pretty rough graph. Okay. It's really not. This is an encoder count. One unit on its grid is a single encoder count. Okay. So we're only dithering plus and minus, pretty much plus and minus 1 count once we're at a constant velocity. We have a little bit of lead error, or it might be a following error, or either ahead or behind, depending on direction reversal. That'll show differently. So what I'm going to do first is that looks, the KA looks a little bit low because we have a fair amount of lead error. KA will affect us mostly during XL and DCL. So I'm going to bump that up and watch this. I tend to hit shift, page up and page down. That adjusts these values by 10% instead of 1%. If you don't hold shift and you just do page up, you'll get 1%. And once you get it close, you probably do want to bump it just by 1%. But if you were, for instance, if you're starting down at 0, it would take forever to get back up there. And you can see as I zeroed that out, our lead error actually dropped off the screen. So we're at about 13 counts of error during XL. Once we're up at max velocity, we're maximum plus or minus 3 counts, which is pretty good on this machine. But I'll show you the effect of bringing KA up. You'll start to see that come down. If I go too far, it'll actually cross over the line and start coming up the other side.
Right.
Okay, so we get a little bit of a double peak there. That's probably somewhere in there is where we're gonna see as I lowered it. The peak got a little bit higher. As I said, there's a little bit of sampling error. Let it go a pass or two. Just because you happen to see a spike on the first pass doesn't mean it's always going to be there. And you can see we actually got a little bit ahead with a tiny little spike there. But I think we can still bring it up pretty well. Yeah, it's still coming in a little bit. Okay, so it's probably about as good as we're going to get. We went from 13 and 14 down to about 5 and 6 counts, depending on. So that's KA. KA again is pretty much we just want to. We're looking at our lead or following error at the beginning of the move and trying to minimize that. KP can be a little bit more tricky. As you get too high on KP, you'll start seeing this will oscillate. I hesitate, so we could actually, we're getting better adding some KP in there, which makes sense. When KP is too low, KP is pretty much a proportional gain. It's difficult. These particular motors, I shouldn't say that because they're rather new to me. These are the Glentech 16-inch pound versus our old 17s.
Yep.
The 17s, if I start getting much above 0.5 in KP, they'd really get squirrely on me.
Huh.
So I'm going to start bringing KP. I want to be careful with it because when KP gets out of hand, it lets you know about it. It'll bang, 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 bang. And
Gotcha.
This is shocking me. Here's another issue.
Okay.
We're in master slave now. If you notice, I've been changing only the master axis.
Right.
We're going to make some software changes so that
it mirrors it.
It echoes the master axis.
Yeah.
But if you're changing the slaved axis, it'll let you tweak that in individually.
Okay.
So what I'll show you, this is the master axis we're looking at right now, which can be interesting. We're going to change it. We can, in real time, change it over to look at the slaved axis and see how that's behaving as we go.
Okay, that's nice.
Now we're looking at the W. That's pretty similar, actually. I think you'll notice we got quite a bigger spike there, and that's probably because of the KP being quite a bit lower than the master axis.
Can you just type a number in there rather than the percentage as well?
In some fields you can. I don't know if this is not one of them though. You can always type a number in. I'm going to save and apply when you're not running.
Okay.
Now
so you can match
in 27.
Okay. Gotcha.
Dynamically, you have to use the page up, page down.
Gotcha. Sure.
So we'll get back to running here. Let me point something out to you. if this screen is up, watch what happens. And this has bit me a couple times, so I finally figured out why I was doing it. The Alt-I screen is up when you go into the PID config menu.
Yeah.
And I start running this.
Yeah. Blanks out. All right.
Yeah.
You can't have that on.
Right. You have to make sure that's turned on.
Okay.
And I think also, you probably don't use this one much. You hit Alt-P and then go into MDI. That displays your PID values while you're doing.
Wow.
If this is on, I think it also has some video anomalies.
Same sort of thing, yeah.
Well, we'll take a look at it and see what it does, just so you can recognize it.
Yeah.
Yeah, see, you
Right,
can see the fields, but now you can't
do anything about it.
Right. So, just things to keep in mind.
So how do you turn that off? Just hit Alt-P again?
You hit Alt-P, but nothing. Oh, it could happen right away.
Okay.
Just, yeah, see, if you're already in MDI, I guess it turns off if you're in there.
Okay.
If you're already in MDI, it won't turn on till you exit and come back in.
Gotcha.
So it looks like, and I always have people do it from out here. I'd say press Alt-P, nothing's going to happen. That's okay, because they'll hit Alt-P and then Alt-P again. Then they go in MDI and go, nope, it's not there. I said, look, just...
Right, there's no indication.
Right.
Okay.
Yeah, for better or worse, that's been there for... That behavior has been there forever.
Okay.
I'm going to just run the W axis up to about where ideally you try to do these one at a time. I mean, try to do them together.
Okay.
It's tough to change this, watching in real time to see what the effects are, then jump down here and change that and see, next version of software that should be echoed over. I already put that in.
Great.
Okay, so KI, when KI is too low, you notice how this error, and this is really pretty nice right now. The error stays centered right along that line. Bounces back and forth one count pretty much. KI, if it's too low, you'll have an offset. So you'll have the same error, but it'll stay up. Offset, a higher KI helps pull it down to the center. I'm going to see if I can lower that a little bit. Again, I'm a little... You can see it starting to shift
lift above, yeah.
This machine is very free. You know, it's a rack and pinion.
Sure, yeah.
Look at the size of it. We're driving it with 16-inch pound motors with no problem. On a heavier machine, you'd see bigger reactions faster. So it's starting. You can see pretty much all of our errors above 0 on there.
Yeah. So you're going to make that number a little smaller, try to bring it back down.
Yeah, try to get it centered so any dithering is done +1 -1 instead of +2 minus or +2 0.
Yeah.
And that's pretty much the case throughout. And again, the error we're looking at with KI is typically going to be at constant velocity, not during XLs and decels. KD, again, if our errors are, if it's too low, whoop, that's what happens. It goes into slower oscillations.
Just stop and explain what you did and what happened.
Okay, I took KD from about 3, and I'll bring it down again and show it slower.
Okay. So you lowered it to go into the oscillations. You passed like a threshold, basically.
Yes.
Okay.
So KD, when it's too low, manifests itself generally in slower oscillations at the end of the travel. So as we're moving, the axis is moving along this way, and we stop, and it'll sponge. It'll go past where we wanted, come back, and keep going. If that K right there is exactly where we wanted to stop, it would go past it, come back too far, and it would kind of just go back and forth,
Sure.
like that as it settled in.
Yeah.
And it's a much tamer oscillations. When KD gets too high, number one, you'll see a lot of singing. You'll hear it in the motors, and most often you'll see that in the DRO. When it gets really too high, I know that you heard the vibration, and you'll hear it again here shortly. When it's really too high, it's like taking a hammer,
Right.
and bang, 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 bang.
Yeah.
So I'm going to bring KD down again, and you'll see it starting to, as it's doing its correction, it overshoots a little bit more than it did, and then it goes back the other way. So we're going to start at 3.12. Taking it down 10% per pass. Now I'm just going to do 1% because I don't want it to get completely out of control. Now, KD, too high a value with KD can often show up as axis idling too high. So sometimes if you're getting those messages, you can try. Yep. Sometimes you can get it back. Yeah, unfortunately, this machine doesn't seem. It's not letting me show you a real gradual change.
Right, because there's hardly any natural damping in the machine.
Right.
Yeah. No problem. It's all right.
So,
What's the goal then with KD? Where do you want to do it? Do you want to bring it as low as you can before it oscillates, or do you find each extreme and then pick the middle? Or
I tend to take it up until I start to hear the motor sing, and then I'll probably back it off 20%, 25% from there.
Okay.
Again, this machine, unfortunately, it's not demonstrating it very well. Generally, you can visually see the effects of KD. In this case, it just kind of stays steady until it loses it, and once it loses it,
right,
it's gone. So I pretty much take it up until the motors, and I'm going to jump out of here real quick. Now you can see that's not too bad. We're really flickering a count, maybe 2 counts. So KD's I'm probably going to back it off just a little bit more.
Meaning lowering or increasing?
Lowering
it even
right.
more.
The higher I get, you'll start to see
more flicker.
5 counts of dithering,
right.
10 counts
right.
of dithering.
Yeah.
Now you're seeing this place, but it's only because it's going 69 to 70.
Right. That's pretty good for a rack and pinion machine.
This is not bad. Yes, this is amazing for a rack and pinion machine.
Yeah.
Our max errors are like 6 counts
right.
during Excel, and at constant velocities are plus or minus 1.
Yeah.
Not always as easy.
Yeah.
And you also notice the PID out isn't jumping around. There's our error. -1, 0, -1, 0. It's holding pretty well. So I'll probably take that down to 225. Save it. I don't want to go too low with it. Try just 2. said, I keep forgetting that. W. That may have also been affecting why it wouldn't let me bring it in, take it out of tolerance gradually, because the W's got power on it too. So that was all done at a 1/2 inch a minute. Now we're gonna, that was all done at 30 inches a minute and a 1/2 inch move. I'm gonna bump it up to 60 inches a minute. Again, I like to hold it about 1 second in each direction. So it's 60 inches a minute, that's just X1. We'll save it. Program. Okay. So I took KD down too low. It was fine at 30 inches a minute. When we got a little bit more inertia going, that's speeding it up.
Okay. Is that a pretty typical strategy? Starting at 30 inches a minute, set it, go to 60, tweak it in more, and then you just keep like going up in speed?
And then come back at the lower speeds. I've seen it where I've had the thing tuned extremely well at 300 inches a minute, and for whatever reason, 5 inches a minute, it's lurching, and you would think, hey, if I can run it at 300, but it's not. It's almost always a case, but you should come back down to a lower speed at the end just to make sure. So I'm gonna.
W.
Yep. Now, I guess it was out of control already, but so as you can see, we've got 2 to 5 counts, 2 to 4 counts, somewhere in there during XL, and then once we reach constant velocity, we're pretty much plus or minus 1. Same thing on D-cell. Spikes a little bit more. I'm not sure why. D-cell seems to do that more than the XL does. Seems to be behaving reasonably. I'm going to save and apply, quit, edit my program. Double my feed rate. Double my distance. Depending on how fast you're going, this isn't that fast. You may want to increase your dwells just so you can make sure that you get down to a zero velocity somewhere.
Gotcha.
If you were, some machines, this might go up to 1200 while you're tuning it. 0.1 is nothing. This will look like a sine wave more than it does a trapezoidal. So let me save that. Let it go back and forth a couple times, then I'll hit zoom all. Zoom all only seems to work right once.
Okay.
So let it
wait.
Yeah. Now I don't know. No, I guess that's right. KD up a little bit. much to go on here other than when I took it down to 2, we lost control, went into oscillations. So I'm trying to just pick it up a little bit, just, you know, on a hunch that I'm going to need to be a little bit higher rather than lower. We're running at 120 inches a minute. It looks fine. I mean, that's in great shape.
You're not concerned about that spike at the beginning and the end?
Not so much. Again, it's only during XL. And typically you're going to see the y-axis is going to spike just like it. So if we're doing, and when that's the case, if we're moving the x and the y at the same velocities, or excuse me, I should say, if that spike scales the same with the x as it does with the y, so we're a little ahead or a little behind here. If the y is a little ahead, a little behind here, then the errors null themselves out. If I'm moving at a 45, and the x is a half a thou behind, and the y is it's a half a thou behind.
Right. Okay.
It's a time thing, not a position thing.
Okay. Gotcha.
And again, 10 counts on a machine like this.
Oh yeah, yeah.
10 counts on any machine isn't bad.
Yeah.
You'll see on velocity mode, GPIO4D, like Delta systems that are running 131,000 counts, you're going to see hundreds of counts.
Right.
But it's still
so
down, down in the fractions of tenths.
Right.
So we'll take it up one more time to 240. Now Sean says this machine he thought would run around 500. I think I can get it up that high, but the concern with the gear mesh, you hear a lot of whine.
Yeah.
And I told him I'd make sure that they were, you know, filled up with lube.
Right. Yeah.
We'll let it run in for a little bit. He doesn't have to run, but his cutting rates are really slow.
Yeah, they got to be 10 inches a minute or something.
Yeah, exactly. So I've just, you know, I explained it to him. He agreed. But, you know, no reason to push it right now.
Right.
There's overhead there, a lot of it, I think. But so 240, 4 inches, 1 second each direction. On program. Okay, you can see at 240 inches, that 0.1 is just enough to stop. You do want to come to a complete stop. So we might try to make some adjustments on KA here. Whoop. So I just hit that down 10%, down another 10%. It's probably because of the rate we're moving, it's not giving us a lot of effect.
And what were you trying to do?
Try to get this down a little bit.
Okay.
And again, you're never cutting at that. So really, the fact that we have 18 counts of error during XL while we're doing a rapid to some place is irrelevant.
Yeah.
Hear that whining in the gears over there? That's why I don't want to take it up.
Yeah, yeah. Light.
The only vibration is gear vibration. There's no control oscillation in that at all.
Yeah.
And I do after I'm done with all this, besides going slow again, is I'm going to take it back down. Let's go to 15 inches a minute. What is that? Oh, I typo. That's what it is. something you'll want to do when you slow it down like that. Yeah. This isn't bad. Sometimes on a fast machine, I'm moving 10 inches. I'm 10 inches away. Then I tell it to do a 1/4 inch move back to 0. You know, it's 5 inches a minute.
Okay. It's going to take
forever. Right. You'll wonder, why isn't this turning around? Something's wrong. Why? And that's what it is. Okay, and so we're still looking at X, and we're just going to go real. Yeah, again, when we're going this slow, there's one count. These are fractions of counts on each grid.
It looks bad, but
it looks ugly, but yeah, it's nothing. And you can, if you like, use the override up and down.
You can.
What's that?
You can override it.
Yep. Doesn't seem to be really affecting us. Did you see how the... now I got it stopped. See how I flattened out the...
Yeah.
So yeah, the overrides react while you're in there. Okay. And the only reason I bring up the override is overrides can induce oscillations. Or,
yeah, sure. It'd be good to test it.
Yeah.
See. So just give me the highlights of what a good graph should look like and what we're trying to achieve. Just make the points and relate them to KP, KI, KD, KA. So
let's do Y real quick. Just want to, especially after I saw how much adding some KP helped. Okay, so we're going to look at Y. So the first thing we need to make sure is we're actually going to look at Y. So we'll switch that over.
Way. Nice.
Okay, so again, these are single counts right now, and if we zoomed out a little bit, you can tell that. Oh, I changed the axis. Whoops. I wish we'd be consistent everywhere with our zoom in, zoom out. Right. So you can see that's plus 10 counts, that's minus 10 counts.
Okay.
As I said, I usually try to bring in KA first.
Okay, tell me how KA is affecting it again.
Let me try zoom all. Okay. KA affects, it's an additive during Excel. It's kind of gives it a little bit of a boost. So the higher KA you put in, the more it's going to hit it just as it does its Excel. It really doesn't have much effect once you're outside of the Excel. So I think I went too far on this, but you can see where it's at now.
That's that spike there.
Yep.
That you're just trying to.
See how as I'm going higher, that spike keeps getting higher.
Yep.
So I'll bring it back down.
Is there a rule on what you start with?
Yeah, it's usually going to come out 0. The default configuration will have a KA of 0.
Okay.
Too high of KA, like I said, will make your machine bang and thump because we hit it too hard.
Right.
Too low of KA just makes it softer.
Right. And you see
which is safer.
Big spike at the beginning.
You can always increase it and try to get rid of it. Now, you see, we've actually gotten that spike. It's half of what it was when I had it up by 25.
Yeah.
And again, so KA is during the X cells and the D cells. That's those spikes there.
Yeah.
KI is
lifting it one way or the other.
Whether it's offset one side or the other.
Got it. KD is the oscillations, the damping.
KD, I'm hoping I can show you. Yeah, typically is going to be at the start or at the end. I see it more at the end, where we tell it to stop and it gets slushy in it.
Yeah, and
we'll walk back and forth.
And KP
is, think of KP as power. It's a proportional gain.
Okay.
Higher we get KP, these graphs are hard to see because we're so zoomed, it's plus or minus one count.
Yeah.
If that were plus or minus 100 and you saw that, I would think KP was too high. Okay. You'll start to get oscillations, and it almost looks like it's modulated. So you'll see like a burst of oscillations, then it'll settle on another burst, then it'll settle on a burst.
You kind of think of it as you've turned up the volume so much with KP that it can't stay in control.
You start getting feedback, kind of.
Right.
And once KP goes, it goes. It's typically these will go off the screen and you'll hear it mechanically banging.
Okay.
KP also, I should mention, KP will also affect that lead or lag error quite a bit. As much as KA probably.
All right. And what are you looking for as you're adjusting KP again?
Well, I'm looking at the lead error, or following error, whatever it might be. We're ahead of where we're supposed to be or behind. And I'm also looking here for when we're holding it, we're putting so much power in there, we'll start to get oscillations in there. And then, like I said, once it goes, you'll know it.
Okay. And
hard to tell. This particular machine, I can feel the vibration in the machine as well.
As you're raising KP.
Right. Yeah. But because this is springy already, it's
hard,
Yeah. Okay, so it's starting to get a little bit.
Yeah, see that lifting up there in the beginning.
And see I said, you'll get a burst of oscillations here and there.
Okay, that's good.
And other machines, see the bursts?
Yeah.
Like I said, you get a burst, it'll settle, burst, settle.
Yep, too high KP.
Yeah.
And
now these are very high KPs, but again, I don't have a lot of experience with these motors. Most DC motors are 29 inch-pound motors. They're pretty much always going to be right around 1.
Okay.
And obviously it's a machine, motor, turns ratio, coder, it's all right.
So, when you tackle something, you got some default values in there. Do you just immediately try to run it and do you pick?
Yes.
You just look at the graph and pick the problem area. It could be KA, it could be KD. There's no order that you should attack. You're just looking at the graph and determining.
KP's if I think KP's too high, especially if it's too high,
you do that one first. Otherwise, you're wasting your time trying to tune the other ones if KP's wrong.
Pretty much, right.
Okay.
And I believe our write-ups state it pretty much that way,
Okay.
Do KP first. When I'm done with that, depending on the kind of machine it is, this was pretty much learned trial and error. Better job. Usually they're like 3 and 5 or something like that. Dead start and Delta V Max.
Right.
Depending on the type of machine, we tend to make those higher. When they're higher, we'll get better performance in big circles where we're going pretty fast. Otherwise, when these are real low, you get what I call a lurching. Okay. Like it'll at every quadrant, it'll excel up to what should be the program feed rate at the 45s when both axes are moving. the same velocities.
Yeah.
And then as it comes out, one axis start doing it. It kind of goes.
Right. Okay. So what do you do in that case?
I increase these.
Okay.
I think the dead starts help smooth that out. Ideally, all you'd hear in a machine going around a circle would just go one.
Right.
You know,
sure.
not that.
Right.
Yes, one axis is slowing down while others are speeding up.
Right.
But the combined velocities should be the same all the time.
Right.
So what I did in this machine, I hit 10 and 10, saved it, and then I wrote this little program just called circles.txt. I'll probably have to jog it out a little bit.
Yeah.
I have plenty of space here, so I'm just going to reset my zeros. I'll graph this for you. This is not rocket science. It's just little circles, bigger circles, bigger circles, bigger circles, just to see how consistent everything stays. Put the feed rate around 100%. And I'll tell you, I'm going to start it over. I'll put runtime graphics on so it's a little bit easier. See where we're at.
Sure.
So run.
Probably 0 tool diameter.
Wow.
It's not showing up.
I don't think. I don't even have a tool in there. That's the problem. I'll put one in. Good call. I don't use runtime graphics very often. See how that's... Now you hear it speeding up and slowing down, but if you look at the motion on that torch, it's nice, constant velocity. We want a constant velocity. What we're looking at.